Today we're going to look at the difference between linear and nonlinear functions. As I reviewed some of your check-in data from the second check-in, I noticed that you are having a hard time with some problems dealing with linear versus nonlinear. And it looks simple in the beginning, but we need to be sure that we're careful with these and some of the tricks that they throw at you that you don't fall for. So let's look at number one. I'm giving you four choices, and it asks which of the following is a linear function. Well, obviously, when we hear linear function, we think a straight line. So I would guess that A would be out because it's not a straight line, it has a bend in it. And then B would also be out because it has a curve in it. Then we look at C and D, and I'm guessing a lot of you saw linear, and the first straight line that you saw was C. But then we have a problem. What about D? Well, the issue here is this word, linear function. So they've thrown in two possibilities or two concepts in one question. If you remember, a function has to pass the vertical line test. And in order to pass the vertical line test, it can only touch in one spot. And we talked about dragging your pencil across. If we drag the pencil across and we hit this line, this would not be a function because it would touch all the way down. C is out because it's not a function. So the correct answer for this one would be D, a horizontal line. One lesson that we need to realize from this is vertical lines cannot be a function. Any vertical line. So when we see the word function and we see a vertical line, we need to automatically eliminate that one. Next, another question that was some issues was question number 5. And again, here we're talking about linear and nonlinear, and it says, which of the following are nonlinear? So we've got one of these that's a nonlinear. So we're looking for clues or hints that things show up that is different from the rest. Now, this one obviously is linear because it's a y equals mx plus b. So A is out. Now, B looks a little weird with the square root, and I'm not quite sure if we've had much issue or much practice with the square root problems, and so I feel like that one is a maybe. Then we look at C and D, and we notice we have fractions. Now, these are still going to be linear functions. Anytime you have a fraction and your x is on the bottom, that's still just a linear function. You could rewrite that with an 8 over 3 minus a 2 over 3. This could be written as a 1 over 3 minus a 9 over 3. It's okay to have a denominator that's a number. That's still going to be a straight line. Remember, fractions are just division problems. So these are both linear. Left over is y equals the square root of x. And if you were to graph that, you could see that it grows like this, and it's not a straight line. Again, what if you plugged in some points just to check it, graph it, see what it would look like? And since this is a square root, you'd probably want to pick perfect squares, like the square root of 100 or the square root of 49, and plugging those numbers in and getting your y. And when you graph those, you would see when you connected them that it's not a straight line. I feel like some of you saw fractions and automatically thought that something was wrong with it and picked that as your nonlinear. Then something that I definitely want you to pay close attention to that shows up a lot is when you have an x times a y and then your constant. Remember, if we were solving this, we'd have to get y by itself. And in order to get y by itself, you would have to divide both sides by x to get rid of it. So now it would be y equals 12 over x. Now, if you looked at a graph for y equals 12 over x, it looks something like this. Again, you could plug in points to check it. If this was a calculator problem, you could see, but we need to understand that when you have an x and a y together, we're going to move the x to the bottom to get this where you can graph it with y by itself, and that puts the x on the bottom for a nonlinear. So you might want to put this example, xy equals 12, as an example of a nonlinear, or y equals 12 over x, another example of a nonlinear. Then we're getting into a table of values. Notice this is calculator active. Let's take advantage of it being calculator active, and we're going to plug this into our calculator and see what it looks like. If I go and turn my calculator on, I'm going to clear my memory. I'm going to press Stat Edit, and I enter in the L1s go under for your X's, so 2, 5, 9, and 11. Your L2s are your 7, 16, 28, and 34. Now remember to turn it on. We have to press second y equals and enter twice, and then we go ahead and press zoom 9, and it looks like it's a straight line. It looks pretty straight to me. Now sometimes these can fool you just a little bit, but here's another thing that we need to do to check and make sure. Straight lines have a constant rate of change. And this one fooled a lot of you. Let me show you why. We're going to look at our change from 2 to 5. That is a plus 3. From 5 to 9 is a plus 4. From 9 to 11 is a plus 2. So you're automatically probably telling yourself that is not a straight line. That is not a constant rate of change. But you have to be super careful, and let's make sure that it's consistent all the way through. 7 to 16 is a plus 9. A 16 to a 28 is a plus 12. And a 28 to 34 is a plus 6. Is that right? Yes, plus 6. Now, again, it does not look like a constant rate of change, but watch how these match up. This 3 goes with this 9. This 4 goes with this 12, and this 2 goes with this 6. So I'm going to put the change in the y's over the change in the x's to see if we have a constant rate of change. That's 9 over 3, 9 over 3, or 12 over 4, or 6 over 2. Well, what do you notice about all those fractions? They all equal 3. Therefore, the change in the y's and the x's is proportional, so it is a constant rate of change. So yes, this is linear, although at first sight it looks nonlinear. So be super careful. Finally, this one is another calculator active, but I'm surprised that we had trouble with this. We're going to draw in our humps to investigate like we did up here. Remember, we're looking for a constant rate of change. And this is a plus 2, a plus 2, a plus 2. It's looking good so far. It looks like a constant rate of change to me. Again, a plus 1, a plus 1, and a plus 1. So let's put these y's over x's and see. 2 over 1, 2 over 1, 2 over 1. They all equal the same thing. This is a constant rate of change. Therefore, this one would be linear. So please be careful. Double check, make sure that when you do your rates of change to look for a constant, go ahead and put your y's over your x's for the changes